Hi guys, welcome to Graphing Quadratics. This video is going to just introduce you to what quadratic functions even are, what they look like, and the general form of a quadratic equation or function. And then each subsequent video will sort of introduce you to a really important piece of a quadratic function and how to graph it. So let's get started. So what are quadratic functions? A quadratic function, you guys, is just a function of degree 2. So this is the general form. It says a quadratic function is defined by an equation of the form y equals, or f of x. And f of x is just a fancy way to say function of x, okay? ax squared plus bx plus c. So this is just a degree 2 polynomial, right? The highest degree we have here is 2. We've dealt with these plenty of times before. It's a trinomial. We know how to factor these, okay? We would use the AC method to factor, right? This should look pretty familiar. For a quadratic function, a, this first coefficient here, cannot equal 0. And the reason for that is if a equals 0, this whole term would go away, and it would no longer be a degree 2 polynomial. You'd be down to a degree 1, right? And that's just not a quadratic function. It has to be degree 2 in order to be a quadratic function. So the highest exponent has to be 2. And of course, a, b, and c are constants, okay? Just meaning that these a, b, and c, they're coefficients, they're numbers, they're not variables. So that's what a quadratic function is, all right? It's just a degree 2 polynomial. That's what we're dealing with here, okay? So now let's take a look at what they look like when you graph them. So when you graph a quadratic function, it turns out it graphs as this special U shape called a parabola, and it looks like this, okay? And I'm sure you guys have seen these before. That word hopefully sounds a little bit familiar, but if it doesn't, that's okay. This is what a parabola looks like, and it will either be like the U shape like a smile, or sometimes it'll be flipped like a frown, okay? So sometimes it will be like this, okay? And as it turns out, quadratic functions and their graphs are incredibly useful in the real world. So parabolas are very special because they have a focal point. And because of this, they can be used for satellites, telescopes, flashlights, and many other devices, okay? So we actually use quadratic functions for quite a lot of things. You can see we use them to design satellites. We can use them to design telescopes, flashlights, all kinds of things. We see parabolas in architecture, in bridges, archways, things like that. And we use quadratic functions to model projectile motion, okay? Like here, the basketball is going to go up, reach a maximum height, and then go down. You see these parabolic shapes. When the football player kicks the football, it's going to go up, 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 and then down. It reaches a maximum height and then comes down. These can all be modeled using a parabola, a quadratic function. And same thing for profit and loss curves for businesses. So parabolas and quadratic functions are incredibly useful in the real world. And we're actually going to see some examples of this when we do our word problems.